Hey everyone, in our work titled VideoClusterNet Self-Supervised and Adaptive Phase Clustering for Videos, we are trying to tackle the task of clustering phase tracks in a given video across its common identities. There are specific challenging scenarios found in the movie domain with a lot of variation in either the pose, expression, or lighting, along with certain heavy occlusions that make it fairly challenging for clustering faces consistently throughout the entire video. Our method starts off with a large-scale pre-trained model. We sample image pairs for every track in the video in order to create a training dataset. We then fine-tune the Face ID model on all these image pairs in a fully self-supervised fashion. This enables the model to learn the different specific variations happening within each face in the video. However, this learning is limited because there is a limited variation in the face within each track. So in order to further facilitate enhanced learning, we soft cluster tracks in the dataset and then sample image pairs from across the matched tracks. So for the next iteration, you take the fine-tuned model weights from the previous iteration and the across track image pairs sampled, and then you repeat this process for n iterations. So this provides, in a traditional sense, a bootstrapping mechanism for the model to better understand the different variations happening in each phase. And while it's doing that, it better clusters the tracks, which leads to further enhanced learning. For the final clustering, we present a novel algorithm that is fully automated without the need of any user input, such as the number of clusters or a matching threshold. The algorithm smartly uses the loss function used in the fine-tuning stage as a distance metric, since it is the most optimal one for a given model's learned embedding space. To talk about the results, we evaluate our method on the Big Bang Theory and Buffy the Vampire Slayer datasets, which are pretty academic standard ones. Among the certain sample crops illustrated here, you can see that the faces are fairly well lit with very little pose variation. So this is an easier dataset in that sense. However, we still outperform all the literature methods consistently across all the different episodes in the dataset. Given the unique challenges provided by the movie domain and the lack of a dataset in the research community, we also release a new dataset along with this work for the same. Titled Movie Phase Cluster. This is a collection of 9 movies handpicked by movie post-production specialists for having really challenging phase clustering scenarios, some of which you can see here in the samples illustrated. The different colors depict the most important varying parameter that is challenging for clustering. To talk about the results, we evaluate our method across prominent literature methods, and we find that our method outperforms all of them across all the 9 movies by quite a significant margin. So this underlines our method's effectiveness in handling extreme, challenging real-world scenarios. To better understand our clustering performance, we provide TSNE plots, where on the left hand side you have the ground truth clusters for each track in a specific movie, and on the right hand side we have the predicted clusters using our algorithm. So in summary, we present a novel video phase clustering algorithm that adapts to a given set of phase track through a fully self-supervised mechanism. Our fully automated approach avoids the use of any user-defined parameters. In addition, we use a model-learned similarity metric that helps provide state-of-the-art clustering performance over other competing methods, and extensive experiments and ablation studies underline our method's effectiveness in handling extreme real-world scenarios. Thank you for listening to this presentation.